Good to see all of you here for our second session here in A1. I'm quite excited for our next speaker. He's done some excellent work in the domain of dates and time in Java with Joda time and JSR 310. We know this guy. A lot of thanks. It's been, yeah, very, very nice. So please welcome for our next session on Java 8 best practices, Stephen Colebourne.
Thank you. Cheers. Yes. Hey, I go around the world. Sometimes I'm Stefan, sometimes I'm Colebourne. You know, getting my name spelled right is never easy. So, hello, welcome to this session, Java SE best practices, a personal viewpoint. So this is me. Been around a while. You can find me on Twitter at JodaStephen. As well as the Joda time, date time stuff, there's other Joda projects out there, Joda Money, Joda Beans, Joda Convert. I actually managed to write a blog post yesterday, the benefits of coming to a conference. So I work at OpenGamma. We're a company, a small startup company. We write open source software for the finance industry, investment banks, hedge funds, allow them to value and calculate risk on their investments. I point this out partly because that's my day job, but also partly because it's a great example of Java 8 coding style. So if you do want to see a bigger project that's using a good Java 8 coding style, as I'm talking about in this talk, there's a place to go and look. There's lots in this talk. Lots of sections. I'll go fairly fast. Nothing will be covered in great detail, but hopefully enough detail for you to get the idea as to why I'm suggesting each of the various points. So let's get started. What is a best practice? Well, that's the definition. Commercial or professional procedures that are accepted or prescribed as being correct or most effective. Yeah. What's the best practice for Java SE 8? Whatever the heck I tell you in the next 50 minutes, don't you know? All right, software best practice is mostly opinion, it's different conclusions, of course, they're possible. You can do pretty much, anybody can come on stage and tell you their best practices. Why should you bother listening to me? Well, I have used Java SE 8 in my day job since mid-2014, since it came out pretty much, and obviously I did author part of Java 8 itself. You must make your own choices. So let's begin. First thing you need to know is use Java SE 8 update 40 or later. Don't bother with anything before Java update 40. It'd be nice if it had been called 8.1, because that would have made it more obvious. Basically, earlier versions have such annoying lambda javac compile issues that you'll just spend your time fighting the compiler rather than actually getting any work done. Sadly, Travis CI, if you know the online continuous integration system, one of their modes still uses Java update 31. So that's a bit rubbish. Right, lambdas. So probably most of you have picked up what a lambda is by this stage. It's an anonymous in class, kind of. It's assigned to a functional interface, so an interface that has one abstract method. And we've got lots of these with runnable, callable, comparator, which we had already. And they use target typing so that the context, so where that piece of code is, that determines the types of the lambda. So here's our comparator example that we've known for many years. That's how we used to write it in Java 7, anonymous in the class, lots of code. It's nice, given that that's the only pieces of information that actually matter in that piece of code. It's nice that we can just reduce it down to something much neater now. We understand it. But how does those types work? Well, we can say that people is a list of person, so E equals person, which means the comparator must take a comparator of person. So if it's a comparator of person, the two types in the compare method must both be person, and therefore, when you actually define the lambda, the compiler knows enough information to determine that both of the arguments being passed in are of type person. That's great so long as it works. Sometimes the compiler doesn't get it right. But what it does allow us to say is our first note here, that basically make use of that type inference. You only need to specify those types when the compiler needs it. So in the top example there, we're just specifying the variable names, P1 and P2. We don't need to say person P1, person P2. The compiler can figure that out for us, and it should do. There should most of the time not be any reason to specify that. Similarly, when there's only one parameter, you have a choice. You can put brackets around it, or you can not put brackets around it. The right way to write that is no brackets. So do that. So hands up, how many people have had a coding standard in their company where you have to declare all your local variables and parameters as final? Not that many, but it does happen. I had it in my company for a while. It was very annoying. Just takes up lots of room to achieve not very much. So previous to Java 8, it used to be necessary that if you were passing an argument into an anonymous inner class, you had to declare it as final. With Java 8, you don't anymore. There's this concept of effectively final. That is, if you have a local variable or parameter that you don't change, the compiler can treat it as though it is final, and so you can just use it within the lambda directly. This is good. So don't declare things as final. You don't need to anymore. It looks silly if you do. So lambdas, we've got another choice when we're writing them. We can write them as expressions, as you see at the top, or we can write them as blocks, as you see at the bottom. Now, in general, you should be trying to make your lambdas expressions, not blocks. If you find the temptation to add in a second statement within your lambda, move it to a method and use the lambda to point at the method. So generally, avoid using those block lambdas. They can get confusing with the return keyword in there. Are you returning from the lambda or are you returning from the method? You're actually returning from the lambda. But once you get bigger lambdas, it can get confusing. So generally, try and prefer to use expression lambdas. We'll see a use case later where block lambdas might make sense. So why would we use these lambdas? Well, you've probably come across cases where you had to cut and paste some code simply because there was some little difference in the middle. This is a kind of example of that. So we've got, two methods, do foo and do bar. They're almost identical except for one little bit of logic in the middle. Now, this is what lambdas are great at dealing with. So what we can do now is we can write a third method that takes a lambda, in this case, a function from A to B, and we can just take the first two methods and call that lambda, just with a little bit of logic that's different in each case. And overall, we've reduced our code duplication, and we've definitely moved forward in terms of clarity. So that's a good thing to be thinking about doing. Right, so these functional interfaces then. They are just interfaces with one abstract method. So we've had these in the past, the runnable, comparable, and callable. But in order to make it work, Java 8 added lots more. So you need to learn what these interfaces are and understand how far they go. So we have function, which is taking you from one thing to another thing. Predicate, which is just returning a Boolean. Supplier, which returns you something from nothing. And consumer, which takes something and gives you nothing. So those are the basic four patterns. And Java util function has lots of overloads in there for primitive types. But it also has something very useful if you go and read the package Java doc of Java util function. It actually has a naming strategy for how these are named in the presence of primitive types. So if you need to write your own interfaces, your own functional interfaces, to match the naming strategy, you can do, because it's been defined there. But in general, you should only write your own functional interfaces if you're actually adding some semantic value. So cases where it might make sense to write a functional interface of your own would be if you've got lots of parameters. The ones in the JDK only deal with one or two parameters. Or perhaps you've got a complicated mixture of primitives and objects. Or perhaps you've got something where you really need to Javadoc to define the meaning of this, the meaning of it's more subtle than some generic interface that will allow you to express. And if you're going to write your own, well, we've got this functional interface annotation which we can add in. Now, functional interface is not mandatory. An interface is a functional interface if it's got the pattern of being an interface with one abstract method. What the annotation does is it makes the compiler ensure that you've only got one abstract method. And it documents for your future maintainers that you intended this to only have one abstract method. So it's useful if you're writing your own to basically say, yes, I really meant this to have one abstract method. Don't mess around with it, please. So higher order methods, if you've ever heard of them, they're just methods that accept lambdas. But because a method accepts a lambda, well, they're just interfaces with one abstract method. And that just means the method signature is nothing special. The method name greet, taking a supplier of strings, well, that's the same kind of method signature we might have written in the past. The lambda is easier for the caller. The person writing the method to accept the lambda doesn't really have to do that much special, which is nice and simple. It fits into the language very well. And that's the great thing fundamentally about lambdas added in Java 8, is that they sort of feel like they're always there. But be cautious, because lambdas use target typing, as we saw earlier, to figure out what the types are. But this clashes with method overloading. So what you don't want to do is have a method overload, two methods with the same name, both of which take a functional interface. So here we've got an apply method taking a function and taking a unary operator. So the compiler now has a much tougher job trying to figure out which of those two methods you intended it to call, given the lambda. Now, there are cases where it works, and there are cases when it doesn't work. And I'm not going to try and explain to you the cases when it works and the cases when it don't work, because you should just do that. Don't overload methods when it's taking a functional interface. If you actually look in the JDK, you'll find cases where they actually renamed methods to follow this pattern when they figured out basically that it doesn't work. You need to have non-overloaded methods. And this one's perhaps slightly more stylistic. The functional interface, if you've got a method that's taking two arguments, I'd argue that you should put the functional interface last and the non-functional interface parameter first. Now, I have found that this gives slightly better error recovery in IDEs. Lambdas obviously are a slightly more complicated thing for an IDE to manage, to deal with. And this way around, you're more likely to get the sensible error recovery within those IDEs. Doesn't matter if you don't do it the other way around, but that's what I'd recommend. Exceptions. Checked exceptions. Well, yeah, I hate checked exceptions. I'm probably not the only person to hate checked exceptions, but I know there are some people out there who still love them and think that they're very useful things to do. Yeah, they're a mistake, really. No other programming language has adopted this, which is a good clue as to their usability. So all these new functional interfaces have been added. They don't declare exceptions. They don't declare checked exceptions. So obviously, if the code within the lambda throws a runtime exception, that's fine. It'll just flow up as per normal. But if it throws a checked exception, as in that bottom case there, class.forName, that won't compile. Because we're trying to declare a lambda that's matched to the function interface. Function interface doesn't throw, class not found exception or any kind of checked exception. So that simply doesn't compile. So the question is, what do we do about this? Well, it's actually not so bad. What we need is a helper method of some kind. Either you write it yourself, or you find a project that has one. In Strata, obviously, we wrote our own. There's other libraries out there that have them. And it just converts checked exceptions to runtime exceptions. Because we all hate checked exceptions, right? So literally, within that helper function, there's a try-catch block. So you're passing in the original function into an interface that does throw exception. The implementation does the try-catch and then converts the exception to a runtime exception. Now, in the version that we have, we actually catch I/O exception and convert it to unchecked I/O exception. So unchecked I/O exception is a new runtime interface that was added in Java 8 So it's always good to try and keep it within the same sphere of exceptions. But you can do that more generally. It doesn't just have to be within a lambda. You can actually get rid of try-catch blocks in your code. If you use uncheck.wrap to wrap any block of code, you actually don't need to write a try-catch block ever again. Now, if you're dealing with libraries that throw I/O exceptions, and you don't actually care about those I/O exceptions represent something where it just needs to fail, then this can actually make your code quite a lot shorter and neater. Just basically saying, it may throw an I/O exception, I don't care, I'll just wrap it away. And as I say there, that's the case where perhaps a block lambda might make sense. So if a try-catch block is quite long, if you had a uncheck.wrap, it might make sense to keep your code in that same format. So unit tests, you can obviously get this same pattern which we've seen. This is the JUnit 3 pattern, where you have to do try, catch, create your thing, fail if it succeeded, expected if it continued in the catch block, all very messy. With JUnit 4 and testng, you had annotations to represent this. Well, in JUnit 5 and beyond, we have something like this. So we can just do test helper.assert throws. So you're passing in a lambda representing the code that you want to test, and you're specifying that that's the exception I want it to return. Now, the great thing about this, compared to the annotation version, with the annotation version, you had to put every individual test for an exception in a new method. Here, I could actually put lots of tests for different exceptions within the same method. Now, some people say that's very bad in testing circles. You shouldn't have multiple tests within the same method, but it can actually mean you end up testing more exception cases, which I think is better and generally a good thing. Right, optional then. The trouble with mentioning the word optional is that it kind of results in lots and lots of debate, lots and lots of fun. Fundamentally, optional is just a class that was added into Java 8. But it does rather polarize opinions. You'll hear views where it's the savior of the universe, that it's the most important thing since sliced bread, that you should, you've just got to do it. Or it's utterly useless and pointless and it has no meaning whatsoever. Why bother? They shouldn't have even added it at all. Get rid of it. I argue that it can be very useful, and hopefully I'll drill into sort of how I use it and how reasonably effective it's been as a result of that. It is just a simple concept. It's a box class that holds a value or holds no value. It's either present with a non-null value or empty, just not there. So obviously, given it has these two states, when you're querying it, you need to determine, is it in the present state or the empty state before you do anything? So how does this map onto null handling? Why is this useful to avoid nulls? Well, that's a sort of comparison at the bottom, really, that you might have written string A equals something or string B equals null. In the future, you could write optional of string equals optional of AB or optional of string equals optional of empty. So now your type system is telling you that I now have a variable that is optional of that string. And that type system, that will follow the code round, follow the variable round, so you'll know that something is optional. But of course, there is another state, potentially, isn't there? Don't ever assign optional of string to null. Just don't ever do that. Really, really, really don't ever do that. And because ultimately, and this is the main argument for why this feature is useless, because there's no way of preventing an optional string itself being null, you end up in this situation where there is a third possible state, and if you have to worry about that third possible state, you've achieved nothing. So you have to, if you're going to use optional at all, you have to be disciplined enough across a wide enough code base that you can be reasonably confident that that third case isn't going to happen. Discipline. So here's your standard code using null. Find foo. So we're passing a key, perhaps to a database, and we're returning the matching object. So previously, you might have had to say, well, if it returned null, then I'll default it, or I'll throw an exception. But what you can do when you have optionals is you have some nice methods that you can use instead. So I just do find foo, and now my type system is telling me I've not got back a foo, I've got an optional of foo, which gives me the information I need to say, well, I've got to default it to a value, or I've got to throw an exception. So that's great. So when you're just doing control space in your IDE, you're seeing that you've got to do some extra step. So when you're receiving that value as a return type, it's great. You've got that extra piece of information, and you can make use of that. And if you do it properly, you're not going to get a null pointer exception there. So yes, the trick is to prefer those functional methods, like or else throw, and there's others, map, and so forth. So you should be preferring those methods. And if you're just going in there and basically writing, optional.if present, then get the variable, you've not really achieved much more than you had if you just did not equal to null. You want to be focused on the methods like or else and map, and trying where possible to avoid the methods like is present. But we work in teams. So remember, some people think it's the savior of the universe, some people think it's utterly useless. So you've got to, when you start using Java 8, have a discussion and choose an approach which you agree on as a team, and you stick to it. Because it is something that requires discipline to stick to one strategy throughout the code base. Those are basically the 5 different ways I think that make sense. Use it everywhere, only on the inputs and outputs to public APIs, only on the outputs of public APIs, the return types, just use occasionally, or just don't use it at all. Those are the kind of 5 ways that make sense. I'm a pragmatic person. I'm a middle ground person. So yes, the middle ground is what I think you should be doing. But remember, you'll hear different opinions. So optional, it's a class. Therefore, there is some memory or performance cost to using it. Now, a lot of the time, that'll get elided away. Hotspot's good at getting rid of those kind of things, assuming you use it correctly. But it's also not ideal to be an instance variable. It's not serializable. So the alternative strategy is to hold null in your instance variable and use the getter to return the optional. So when you call get foo or get surname, within the get method, it does optional dot of nullable and your surname variable. So when you call the get method, it creates the optional, and then you're going to immediately unpack it. Hotspot's great at getting rid of such short-lived objects. So in terms of the length of time that optional exists, very brief, hopefully over time, gone entirely. So the JDK authors originally did add it for return types. That was their goal. I've personally found that if you put it in parameters, it's just really annoying. So I've got a surname string, and my method now takes optional string. So I've now got to manually box up my surname string into an optional just to get it into my method. That seems like extra effort. So if you want to read more about the approach I've just described, that's the blog post, Pragmatic Approach to Optional. Can this work as a strategy? Yes. So Strata is a relatively large code base. It took 2 years to write, and it has no exposed nulls whatsoever. If you call a method on Strata, you will not get null returned. All the methods return optional. Only within a class will you see a null. So those instance variables, they store null, or they're not null checked by the constructor, with the getters returning optional. And the reality is, null's just not a problem anymore. So I can come along, use Strata, I know I'm going to get no null back from it, and I know I'm not going to get a null point exception. If the caller chooses to misuse the optional, well, that's their problem, not my problem. And it's great. It means that when you're actually writing business logic, you don't worry about null. You just know it's not going to be there, and it removes a level of burden. But you have to be disciplined enough across a whole code base to adopt this as a pattern before you start to feel, I don't have to worry about null anymore. Now, if you go to other talks, if you hear various people talk, you'll hear words like monads, and you'll hear lots of sale pitches from functional programming, from other programming languages that also run on the JVM, beginning with S, where you'll hear things that you must use other things like either or maybe or try, that you must use extra libraries like Java Slang or functional Java, and you must go really deep down this functional programming rabbit hole because it's the greatest thing ever. You should hear alarm bells in your head. Okay? You need to think about whether that advice is really right for Java. Java is not a functional programming language. It was not created as functional programming language. It's never going to be a functional programming language. That does not mean we cannot learn things from functional programming language. It does not mean we should apply some of those tips and tricks, particularly around immutability, to Java and our Java code. But we should be writing Java, not some crazy functional version of Java that doesn't really exist. Streams. So it's been said that design patterns are kind of an indication that your language is missing a feature. And so streams are kind of like that, really. They're like design patterns. Loops are often written in the same way, that you do a loop, that you do an if statement, and then you capture those things and copy them into another list. And these are regular things that repeat themselves again and again. But now we have lambdas, we can actually abstract that out with the lambdas passing in those interesting bits. Here's our example. We're loading some trades. We're creating an array list to capture valued trades. And we're basically going through all the trades and saying, if they're active, calculate their value, and add them to the list. But ultimately, those are the interesting bits in that code. So can we express that more succinctly? And this is what streams allows us to do. So our if statement becomes a filter, and our conversion, so where we're doing that present value step, we can map, and then we just collect it into another list. And this is great, particularly if you're transforming one list into another list. That's a great kind of use case for streams. And of course, we can magically make it go faster by putting parallel stream in there, can't we? Well, life is never that easy. So don't overdo it. When we started working with streams, various people on the team, there was this concerted effort to make sure that every for loop was replaced by streams, which is, of course, a dumb approach to take. Streams do not address all the use cases. Sometimes a for loop is a lot easier to use, a lot easier to read, and particularly if you're dealing with maps. The stream API was not designed to deal with maps, only with collections. Why was it not designed to deal with maps? Java doesn't have value types. Java may have value types in Java 11, who knows? But ultimately, because you have to create this extra box to wrap the key and the value together, they didn't want to lock in an API, a stream API for maps now that locked in the fact that that box existed. But if you want to stream over maps, and it can be quite nice to do so, it's perfectly possible to write a class like mapstream yourself and perform those same tasks. If you want to see what one looks like, have a look at the mapstream in Strata. You'll find equivalents in other libraries. You do need to benchmark if you're using these in critical sections. Are streams faster than loops? I've seen comparisons where they are equivalent. I've seen comparisons where they're slower. You just need to check. If you care about performance, you just need to check. Parallel streams, well, it's one of these things that was kind of like a nice idea, a nice motif that you could just switch stream to parallel stream. And if you had a big list, then suddenly things would go faster. But the thing is that that's using a shared execution pool. So if you've got one piece of code over here using parallel stream, and another over here using parallel stream, and a third and a fourth and a fifth, they're actually all sharing that pool. So you won't necessarily get the benefits that you think you will. The number of use cases where parallel stream is actually beneficial is actually really quite small. You need a large list of something that's computationally heavy before you tend to get any benefits. So don't get too excited about parallel stream. You probably don't want to use it most of the time. Method references. So method reference is just an alternative way of writing a lambda where it points to a method. So if you were to put a code like this into IntelliJ, we're filtering where we're basically doing T, and then we're calling the method isActive on T. IntelliJ would helpfully say, you should change that to be a method reference. Only thing is that I've found that quite a lot of the time, you end up changing and refactoring code, for example, to add in an extra parameter. And then you have to manually go back and change it back from a method reference to a lambda again. And I just find it really annoying converting method references back to a lambda. Your mileage may vary on that. Make your choice, but be aware that that IntelliJ hint is not necessarily always the best advice. What if you can't get it to compile? So we've got this stream here. We've got trays as a stream, and then filter, and then map, and then collect. And you can get some of these that get really quite complicated. Imagine what the poor compiler's trying to do. It's trying to match a T here to an E here to a question mark extends here to a question mark super here. Poor compiler. Gets a bit tired after a while. And sometimes it can't figure it out. That's just how it is. If you're getting that kind of situation, I found this to be the most effective strategy to just extract each of the lambdas out to a local variable where you can actually make sure the types make sense. So it is a predicate of trade, it's a function from trade to money. Get it compiling that way, and then reintroduce them back in. And what you will probably find is that somewhere you need to specify a type. So whereas most of the time you can just use T goes to present value, on occasion you might need to specify the type as being a trade. It will happen. That's generally the best strategy for dealing with it. The collector interface. So the collector interface is quite a complicated thing that's typically used at the end of a stream. So if you look at the end of this, we've got collectors.toList. And most of the time, you'll begin by just using the ones in the JDK. But if you're using Guava, where you've got immutable list that you want to create, or immutable set, or immutable multi-map, in those kind of situations, you're going to need to write your own collector. Now, as it happens, Guava 21 is now out, which does have them in already, so that's good. But when we started Strata 2.5 years ago, we had to write them ourselves. But there will be other occasions. We've got examples where we're combining representations of money together to form a multi-currency money object. And combining those efficiently, a collector is the right way to go. So you do have to occasionally write your own collector, learn to love it. It's not that hard, really. Debugging them, yeah. Debugging streams, there's no good answers, really. There's no happy situation. The code path is very big. It's not an obvious code path to follow. You don't want to be debugging through all the Oracle written classes. That wouldn't be great. I wouldn't return stream from a method very quickly, because obviously if you're returning stream from a method and then maybe returning stream from the next method down, you're just making your call stack even bigger and bigger, making it even harder to debug. You might get some performance benefits out of that. You might not. You see, here is the stack trace of a stream inside a stream. So effectively, I'm looping around one thing and looping around another thing, a for loop within a for loop. And that's the stack trace of a for loop within a for loop. I'm just here to make you think, is that necessarily what you want clogging up your logs? So streams are not always more readable than loops. You do have to keep in mind that the goal of writing code is so that you in 6 months' time or somebody else in 6 months' time can actually read it and understand it. That should really be the goal of the code you're writing. And those exceptions in streams, they can be much worse. So I tend to now use streams for small localized bits of logic. So where I am just transforming a list into another list by if statements and filtering or mapping. And where I'm dealing with very large-scale logic, so like right at the top of my program where I'm looping around the entire world, I'm not convinced I'd use a stream for that very much. And in fact, in Strata, we took streams out of that top level and we replaced them by for loops, precisely because we didn't want those massive stack traces in every one of our, because it's at the top of the program, every single stack trace would be getting it. It wasn't going to be helpful. Cool, interfaces. So interfaces have added superpowers, default methods and static methods. So default method just means a method on an interface with code in it. Great. And a static method is just a static method with all the code in it on an interface. Cool. Now, although all the focus has been on lambdas, in terms of your design of your system, methods on interfaces potentially, in my view, is more important. It's more significant with what you can now do. You can obviously extend interfaces without breaking compatibility. That's a good point. The only restriction fundamentally is that you can't default equals hashcode into string. So now, consider this. Instead of a factory class, so instead of writing foo factory, which Java has been notorious about for many, many years, just put the static method on the interface. I mean, why wouldn't you? Why do I need a separate factory class half the time? Instead of an abstract class, I can just use an interface method with defaults. In fact, the only time you'd need an abstract class is if you actually want to have some state, some instance variables within the abstract class. But you shouldn't be doing that anyway, because that's pretty much a bad idea. So if you follow this, what you actually end up with is fewer public classes. Let me just see. Yeah. Because if the factory method is static on the interface, and all the API methods are on the interface, why does my implementation class need to be public? Your whole package, which used to have a public factory, a public interface, and a public implementation class or two, can now just reduce down to one public interface. And that's simpler for callers, simpler for everybody to understand, and easier for you to maintain in the future without breaking any of your callers. It's definitely worth thinking about that and thinking about the macro design options that go with that. But now we have lots of different kinds of methods on interfaces. In my opinion, you should be writing public static, public abstract, and public default on the methods in an interface. If you think about it, on a class, if you omit those keywords, you end up with a package scoped method. Whereas if you omit them on an interface, you end up with something that's public. Well, that's a bit confusing in its own right. What if Java had originally had methods on interfaces from day one? If it had done, this is what the coding standard would have been. So this is not unreasonable. But I think it's even more critical because in Java 9, there will be private methods on interfaces. So just leaving that keyword out, public out, it's even less clear then as to what the meaning is. So I would strongly advise you to consider using those keywords on all the methods in interfaces. Date and time. So yeah, there is a new date and time API in Java 8. Hooray. It does cover all the things you need. So it's basically 80% of Joda time. It's the bits that made most sense to go into the JDK, and hopefully not the mistakes that Joda time has. So those are the main classes you're going to use. Local date, which is just the date on its own for a birthday. Local time, when does my shop open today? Combine those two to get a local date time. Offset date time, that ends in the offset. So here, in winter, in Stockholm, we're 1 hour ahead of Greenwich Mean Time, UTC. So that's the offset, it's the 1 hour. But if you want to represent the fact that time changes from wintertime to summertime here in Stockholm, you need the time zone, you need zone and date time. So that's the difference between offset date time and zone date time. And an instant, well, that's just a point in time. So you are to move away from Joda time. Move away from Joda time. Joda time has had its time. Ha ha ha. And yeah, don't use date and calendar because who would want to use those? If there isn't enough stuff in the JDK for you and you have got extended needs for date and time work, there's a project called 310 Extra on GitHub, which I really need to release another version of, and that has extra things in it. So it has some of the things that didn't make it into the JDK that you may well find useful, including other calendar systems, including conversions to TAI, UTC with leap seconds, etc., etc. But yeah, focus on just the most useful types. There's lots of flexibility in there, and do make use of those offset time and offset date time if you're using XML or JSON, because that's exactly what you need. There are also interfaces. So there's an interface called temporal accessor. Those are intended to be internal interfaces within the framework of the date and time library. If you use a list, you tend to write list of string equals new array list. You have the interface on the left and the concrete type on the right. But with date and time, you should have the concrete type on both the left and the right-hand side of your equals assignment. Final section, there is lots of other stuff in Java 8. We finally have a base 64 implementation. There's stuff to handle numeric overflow added as part of the date and time work, unsigned arithmetic, better annotations, repeating annotations. You can get those method parameter names, assuming you use a command line flag. And JavaFX is finally ready to replace Swing. And we've actually had some good experience with JavaFX. So if you do write GUIs, worth giving JavaFX a go if you've not already done so. Finally, favor immutable classes. So the thing about, it's one of the key things from functional programming that we should be adopting. And Java has, and the Java code I see continually uses mutable code, where really immutable code would be much better. So in Strata, pretty much everything is immutable. Now, it's really annoying trying to write immutable code by hand, trying to write some kind of bean by hand for immutable. So we use Joda beans, which is, funny enough, another one of my projects, to generate immutable stuff. So this is the code here. So I've got a bean definition annotation. I'm declaring it with a style of light, a factoring method of, extending an interface, and all I have to do is just define the field and mark it as a property definition and maybe validate it, maybe specify that it overrides another method, all the stuff like that. And then it will go away and generate you all the various things you need. So it's generated me a factory method, an of factory method, or a constructor, things that allow me to avoid reflection by looping over them as properties, or my getters with nice Javadoc, equals methods, hashcode methods, and 2 strings. But the great thing is that it's not a one-time generation as you might get in your IDE. When I save it, it will create me an additional method on here, extra parameter, extra thing on the constructor, extra getter, and adjust all the equals and hash code. Do you really want to write all your beans by hand? And if you want to, rather than choosing style equals light, you can also get it to generate, let me do it this way maybe. On the right there, you can actually see we've got a builder So you can actually build objects, immutable objects on the fly. You don't necessarily need, you don't have to write that by hand either. So yes, use immutable classes, but use a tool to create them, because otherwise you'll go mad. Cool. So Java 8 is great. If you're not using it, go use it. Go and bash your boss's door down until he lets you use it, and complain and complain and complain. But it's different to Java 7. It's Java, but not Java as we know it. So you have to go back and you have to rethink those coding styles and rethink the standards that you have been using before, particularly around methods on interfaces. You have to think through what that can allow you to do, because it does give you new design techniques which you did not have before. And yeah, just be aware that not every piece of advice from functional programming or other programming languages that may be on the JVM, they don't all apply to Java. It's great to listen to them, but you need to be coding Java if you're using Java. Sounds sensible, but always a good thing. As I said before, OpenGamma Strata is a good example project if you want to look at code base that was written from the ground up in Java 8 that doesn't have any problems with nulls. Or if you're in finance, come and talk to me about finance. Happy to talk about that. If you've got any questions or feedback, this is a Java 8 best practices talk. Or if you want to talk about date and time or Strata, you've got my Twitter handle. Come and badger me afterwards. I'm out of time. I hope you've enjoyed it. See you soon. Cheers.